object amagi length on dun hai se I want to find the length of an object, so I need a ruler. Scale am daga tare. So this is my ruler here, and I can mark taro thame. And sidena si book se kya it's 1 centimeter, and I have divided this into 10 equal divisions. Each of this se kaya hoide no. Let's see. So the least count na hari se the smallest possible measurement nangi device na or instrument na piba ngamba smallest quite a pick pa value though, the smallest possible measurement your instrument or device can give you when you use it. Madu bukuna least count hani khangne eko. As you can see from here to here, say value kya no, it's 1 centimeter. It's divided into 10 equal divisions. Division tara thong khai do. You can count the division 1 2 3 4 5 6 7 8 9 10 ko aduna 1 centimeter do tara thong na khaidala taragadi. If you divide 1 centimeter into 10 equal divisions, you divide it 0.1 centimeter tare. So each of this division, each of this, the smallest division or the smallest possible measurement, in my case here in this example will be 0.1 centimeter. All of these are equal. This is 0.1, this is 0.1 and so on. So the smallest possible measurement in this instrument or in this ruler is nothing but your smallest division here. 0.1 centimeter. So the least count of this ruler is 0.1 centimeter. Get it go. Least count has quite a big value do nangi instrument in piba ngamba. Nano seasonable matamta. Madu least count harib. If karigumba, if Nico Hari say, if you could further divide this into again, let's say it was further divided into 0 1 2 3 4 5 6 7 8 9 10. So how many divisions are here from here to here? There are again 10 divisions. It's 0.1 centimeter. It's again further divided into 10 equal divisions. So each of this division 2 3 4 5 6 7 8 9 10. So each of these divisions kaya hoido no hoido. Haibadi 0.1 centimeter. So in short, well, how do we find it out? Each division it's very easy. 0.1 centimeter though it's divided into 10 equal divisions, so you get 0.01 centimeter. So this will be the least count. Get it? So sumaina amka kopna do divide to biram taragadi masigi ruler sita scale sita sumaina marks hakpiram taragadi magi least count to 0.01 centimeter ta do ne. I hope you get the idea. Any instrument amagi least possible measurement to quite a pick na piba ngamba magi value do buke kawi do least count hane kawi. Okay go. Now maximum possible error hane ju khang mas. Go. Least count or maximum possible error na hane khang ba. Agi instrument se the least count say 0.1 centimeter tare. Okay go. Asidi this was in city karigumba if hiberniko simutalas. I hope you get the idea. Now why maximum possible error hanus ko idu kagino yengsi ko maximum possible error hanus khangne least count. Let's see why we call that least count say maximum possible error hai is kagino de yengasi ko gyan tana bai ruler mu pusale. This is my ruler. First let's find the least count. See rulers ki least counts kya hoto ajeba sitaina se book se right sitaina se book se 1 centimeter ni se book se 1 centimeter ni how many divisions kya la sita 10 equal divisions here. So just like before, the least count will be 1 centimeter se division tara tungna khaidale. So each division se kya horani, the smallest division here 0.1 centimeter. So the least count of this ruler is 0.1 centimeter. Simahana khangdue ko. Let me write it here. 0.1 centimeter na khangdue. Fine. With that in mind, let's say you have a thread. Langamale reba. Masi tingdhoga. You want to find the length of this thread. Now you stretch it. So and you get something like this. So what is the value as you can see here? See kya no? See value say if you do it nang soidre kaimta soidre hai tardi it looks like 1.2, right? Masing thira gyang 1.1 1.2 ko. But if you made a mistake nang soiru targadi, let's say you start from here, sigi 0 do sita lere ko 0.1 am chena ba. Let me zoom in, zoom to yadra male. So let's say you made a mistake and you did like this. Adu targadi 0.1 am chena re. What is the value? 1.1 1.18 1.1 1.2 1.3 tare. Now you'll be saying the value is 1.3 if you made a mistake. Yeah, go. Or in other or if you made a mistake like this, 0 do nang na henjal lu de. Okay, here 0 is the go. 0 is here. I hope you can see it. 0.1 am henjal level. Adu itaragati values again. Now it's 1.1 higher. Say it's 1.1 1.1. I hope you get the idea. Go. Now nangna soigin soirabada nangna soiba matamda 0.1 ama cheneba. What is the difference here? There's a difference of 0.1. What is the difference here? There's a difference of 0.1. These are all centimeters. Go. So it seems like the value lies somewhere between 1.1 and 1.3 mark lebi monga. Go. Nangna soigin soirabada chena doise 0.1 neb. Even you, let's say you made a mistake, and what is the maximum possible error that you can make? It's by a factor of 0.1 centimeter generable. Why? Because the least count of your instrument was 0.1 centimeter. Yeah, that right. So again, the least count to give value to neighbor. What if you have another instrument, another ruler, which is even more detailed than this? Yamna precisely on bangam yam kopna yamna high grade quality instrument nama ruler man seasonal khalase. Let's say this is my ruler. Let's remove this. See ruler lo thor kase. Ko. Now I have done some marking here. Ko. I will zoom out and utke. Now you will see here. It starts here 0 to haure, then goes up to 1, 1.1, 1.2, and so on. Ko. So let's find the length here. The same measurement now. I zoom out. I hope you can see it. Let me draw it. Okay. That's too big. Now from here you're drawing. Now you're saying it's like this. Okay, never mind. Okay, it's not easy. Go. Let's zoom in. 0 mapa sana hanji. Masih kitang kok chang dori ni. Masih dada bata. Okay, it's here. Now let's see what is the length. I have done some marking. Go. What is the least count here? Yung. From here to here, this is 1 centimeter. Ko. 1 centimeter. It's very minute. See the from here to here, this is 1 centimeter, and it's divided into 10 equal divisions. Ko. It's divided into 10 equal divisions. Each division here, the smallest division here is kiano. Let's find the least count first. From here to here is 0.1 centimeter. It's divided into 10 equal divisions. 0.1 centimeter is further divided into 10 equal divisions, will be 0.01. So the least count of this instrument is 0.01 centimeter tareba. First, let's write it here. So the least count is 0.01 centimeter. Now you did the measurement. All again. This is your thread now. Now what will you say the value is? Now its value, as you can see, slightly more than 1.2. Slightly more than 1.2. Let's say it's 1.21. 1.21. The smallest measurement is 0.01. The small gap here is 0.01. Up to here is 1.2. 1.2 to that. You add 0.01 adu kya tare 1.21 tadro. The small each of these gaps here are 0.01 yareko. Fine. Now pare, this is how you find the marking. Next example dana, let's say you made a mistake ko soibadagi nang se soibadagi 0 mapa chanadreba like this. You started like this. Nang ano upa kaura, you forgot to wear your glasses and you get something like this ko. Let's say it's here. It's not easy to do this. Okay, I hope you see it. Some side nang 0 kitang chanadreba mapa se. Then and the tip the matono sumana, this is how it looks like. Now you might say this is, oh, now it's 1.2 exactly 1.20 hertz ko yare ko haning is. Then what if you make another mistake and you started something like this? I hope now you're getting it. 0 ma pa je kitang henjen na 0.01 am henjen lag so. This is how you started the measurement. Adu itaragadi now you'll be saying it's katayang se somewhere around here. It's here size ma pata. And how much is this value? See the 1.2 like right up see your target is 1.21, see your target is 1.22. Now you'll be saying it's 1 point, let me write 1.22. I hope you again tani khalai nai tori se mun adum yemu. It's very easy ko. So mapa chana gonna see general gonna either this or this if you made the mistakes here. So what is the difference here? 1.21 dagi 1.20 khaido it's 0.01, right? Again, what is the difference here? 1.22 dagi 1.21 khaido you get 0.01 again. So the error that you could make, the error that you made, sidasu 0.01 ni, sidasu 0.01 ne. So the maximum possible error that you could make, angna chain gen general bata ana soiba yaba value to kya no nang soide se will be the least count. For the first case asu when kuna ruler ma seasoner to su chaman ta ki ko the least count. So I hope you get that. Ngasagi to budana this was our case. The first case though it was like this. Sidagi horga you did like this. Either you get sitabama 1.2 tabama 1.2 tabama, or if you made a mistake you got 1.3 tabama, or if you made a mistake like this you get 1.1. What was the possible maximum possible error here? 0.1. Generally is 0.1 here. So in this ruler the least count ruler in this ruler here the least count was 0.1 here. So the maximum possible error that you could make, that you made, was so again sort of that 0.1 centimeter. That was a possible error. Here, least count. What was the least count here? 0.01. So the maximum possible error that you made here is 0.01. Least count to give value to never general. I hope you get the idea. Why least count say it's also known as maximum possible error and highs, because general bada madugi value to name. So hence the name ko least count to maximum possible error and highs. I hope you got a brief idea why least count say maximum possible error highs kaigino ito ko. If you made a mistake, what could be the possible error haiba madudinit. Okay, sibuk yaren khale. Now the sibuk yaren khale ko. Now the example macham kanom example nati kanomaga question ma hangba yai. Sir fare, so you're telling me that to find this length, which is of 1.2 exactly, the maximum possible error is the least count of this ruler, which is 0.1 in this case. So the maximum possible error is 0.1. Higher. Why not 0.3? Why not 0.2? Why not 0.5 na hangeb? Let's talk about that ko. Sigi ruler zi yengase ko. Akoy ngasai dik dum to la bani mase magi list count si kya na koi khang lai grabni. Adu anyway sai koi ki measurement kya na lo ido 1.2 da koi example lo kidana. Let's do it again. 1.2 ko hanan lo do waram mani. Anyway, bear with me. So magi length say 1.2 neb ko nang soi gi na soi rabada kya ba either sumaina to budi soi budi 0.1 ama henjan budi sida 0.1 ama sida henjalis ko nang what na hagira hen na hagira sida side gi 0 mark to side ni loksal lure ko 0.1 am chenera ga you get if this is the case nang soi budi you get 1.3 tare or nang soi budi sumaina soi bo bu ko the target you get 1. 1.1 tareb. So the error here is 0.1 centimeter ngatani ko se 0.1 centimeter, which is nothing but the least count of this instrument. Sigi instrument sigi least count sigi ruler sigi least count se kano 0.1 centimeter tare kegi no adu height su yarabin khale sidena si book se 1 centimeter ni it's divided into 10 equal divisions. So 1 centimeter divided by 10 is 0.1 centimeter tare ko least count is sinip why not 0.5 chena but 0.5 yung chena gadi masi maram chaga drai do madu hydrogen da. Let's talk about something. Let's say you want to meet someone lunch or dinner lunch ne harasi pung amada una zen high greba me ma friend or girlfriend or boyfriend I don't know pung amada date lay harasi but pung amada date lay do you reach by pung amaga minute mangada pung amaga minute mangada yaure that's reasonable asi am tini reasonable oi ko minute manga ka ji thengra bagumne but instead what if you reach by 4 pm da pung amada unagadab do pung mari do una taragadi madudi soi ba hai kitra madu henman greba what is the error here 3 hours what is the error here 5 minute eko ana minute manga ka ki difference macha ama list haidi yam da we call this as an error pung ahum thing madudi can we call this as an error? That's not an error. Nang mido either you don't like him or her I don't know you're not interested data nang thawa yaudi hai tare so soiba na hai du se kitang taningi ba value dagi kitang nak na lera kanda ihe haraga soiba ne hai badi yai another example amadana let's say nang chak kanom sador you want to eat something ko nang sador to let's say let's say you had some kind of injury na khut sok pani hangde muscle pain to ni hangde whatever the reason ama oil ase so chinban do hook do you miss it and hit the nose ko you want to feed something to your to your mouth you want to put something to your mouth a piece of I don't know support ama pijaning hai see but instead of inserting in your mouth to your mouth you hit your nose. Is that a mistake? Yes, slightly reasonable because your nose is very near to your mouth. Or you hit your chin khadang dom hook ureba chin ban do hook da naton dom hook khadang dom hook that's reasonable hai madu yam kana lapna banatina ni moi gi listen so but you miss your lips and hit the back of neck or you miss the lips and hit the back of your head chin ban do hook do lukham do hook taragadi madu soibina hai agitra that's a very I don't know karam tore di ko kutu kadai pa hai bi question am lak tore chin ban do hook do thabak to hui haragadi that's not reasonable again. You miss the lips, you hit the chin. You miss the lips, you hit your nose. That's reasonable. Aduna, this is your target, but you hit here. Reasonable because it's not very far away. This is your target, but you miss here. That's reasonable. It's not very far away. Aduna, soiba na haidu se kitang taningi ba value duga tarai duga kitang nakna lera kana soiba haidu ne. Reasonable oyeba. Ko. With that in mind, and haning se lokshan bang amringo. 1 point. Let's rub this off, all of this. 1.2 sang ba object mi si se lady se accurately on ba matam da 1.2 sang and hide si 1.2 sang ba object to nang na on ba matam da soi badagi sumaina amuk soi to badagi sidana 1.3 tare sumaina soi ragana ko 0 gi mark to nang na ama channel raga sida lower badagi or sumaina amuk soi boy taragadi kya tare 1.1 tare so see reasonable oyeba so with the reasonable over value never what is the error here 0.1 what is the error here 0.1 the maximum possible error here is 0.1 centimeter 0.1 centimeter what if nang sumaina soi basi yabre you thought this is the 0 mark 0 do sidala en khalaga nang on ba hore 0 an haraga 1.1 kya tare 5 lere 6 7 1.7 na hareba nang measurement to 1.7 and loksal leba 1.2 ta ga dabto. What is the gap here? Kano 0.5 ki kano generate 0.5 ki error am le reba. That's a huge error. Gyan tabra 1.2 sang do 1.7 sang bese. Or you did like this 0 gi mark to nang swai dang loksal reba. Sum exaggerate was example se ko 0 this then loksal reba do ga sida 1.9 yok thokreba. Adi can you say that 1.2 sang pot to see 1.9 hai bi yagadra ba? What is the difference here? What is the error here? 0.7. That's a huge error here. Yan ko yam thini khena greba. Aduna ngasai mamangi daina haibada why not maximum possible error do least count to oini hari se kaigino least count is oini hari se kaigino hai taragadi reasonable oibigine modi yamne hendo ki taragadi art thokchalakta 0. Least count na 0.1 centimeter leraga maximum possible error na 0.7 jena taragadi. That's a huge problem. Something is wrong with you. It's not about maybe you have forgotten your glasses, but it's not just about the glasses. You're being very careless or something else or some other reason. Always maximum possible error say the least count of the instrument. So far, I hope so good. And now coming back to this example, what was our measurement? Length 1.2 ni hai se ko 8 kitang chena bro. So this is 1.2 hai se. So 1.2. What was the least count? 0.1. Chare ko 1.2. Adabu if you made a mistake, so maybe you got 1.1, maybe you got 1.3. Yeah, go. So let's say you are a very honest guy. You know the answer is 1.2 because your teacher told you nang ozana har padi 1.2 ne nakok ta dikhange, but nang soi badagi sometimes you get 1.1, sometimes you got 1.3 because you made some error by this value 0.1 centimeters. And so you tell me, sir, the value may lie somewhere between 1.1 and 1.3 ki mark ta le the value may lie somewhere between 1.1 and 1.3. You're being very honest here. Centimeter. Is that reasonable? Yes, that's acceptable. Madu adu 8 1.1 and 1.3 book mark leranguni I 0.1 gi kano my 0.1 centimeter ama general because I forgot to wear my glasses or something happened and I was in a hurry or something. Nang hobe on badagi soi kimne hai bani khangde ama ano upakaw ho budi hai bani khangde masi reasonable. If you report this value to me, I want to see the value report or matam, I will accept it. That's reasonable and high gani. Now observe this pattern here. So when you take the measurement as, now let's rub this off. When you take the measurement as 1.38, 1.3, what is the least count? 0.1. Now observe this pattern. If you take the measurement, see meaning the 1.3 least count ki 8 budi khange 1.3 ki measurement am log bada or 1.2 1.2 high taragadi centimeter high taragadi least count is 0.1 and higher. It can accurately measure up to one place after the decimal hiding in able. Likewise, if I take a measurement as 5.2, that's scale 5.24 sang object centimeter length. What is the least count high matamda? You'll say 0.01. If object ama 6.214 sang ba length. What is the least count high? You'll say 0. 6.214 sang object ma my length to sin high matanda. What is the least count high? You will say 0.001. Now pattern zero. C or badana least count is this, C or badana least count is this, C or badana least count is this. In this case, see last digit say 1 on money. Yarba. The remaining digits are all converted into zeros. Yarba. And you put the decimal as it is in the same place. Here you go. Observe this pattern. For this, whatever instrument you use, the least count of that instrument will be 0.001 centimeter. Whatever instrument you use here, the least count will be 0.01 or a centimeter. Go. Aduna sigi patterns observe though. Now if that is the case, Now let's observe this example. See example G. Length kama C ne hareba. So what is the least count? 0.1. Hasik haiba concept niko. Last digit to 1 don't to haido. The remaining will be all converted into zeros and keep the decimal in the same place as it is. Here go. So these are the least counts of this values here. So if you know the least count, the value may lie somewhere between. Kya hai ne? Subtract this from this, you get this. Add this to this, you get this. Subtract this from this, you get this. Add you get this. Likewise, subtract this from this, you get this. Add this value to this, you get this. So the values may lie within this range. So please understand all this. Sibuk tawin khalasi. Now the side ki tawai se karino hai taragadi. Koi nga side ta ise kaino. First koi least count or maximum possible error. Je kaino. Least count se maximum possible error koi non khangre. Least count se or maximum possible error se always least count to oini hai gre. Why? Kai gino chinban do huk do khadang do lukham do huk yaroi. If the least count is 0.1 and you find the length of something to be something to higher and if you find the length of something to be 1.2 some object after you made some mistake, it could be you may get 1.3, you may get 1.1, but you getting 1.9 and say the maximum possible error is 1.2 sangada to 1.9 phangzalaga, maybe you made some mistake like this. That's a horrible mistake. And you are telling me, sir, the maximum possible error could be 0.7. Maram jade heba. Habi pung amada chatkadaba date to pung marida yorpado. We don't call that as a mistake. Say the least count of your clock is 5 minutes and you reach there the venue by 1:05 p.m. That's reasonable. That's a mistake. That's an error. There's an error of 5 minutes here. But saying there's an error of 3 hours here, this is not an error. But it is palm tanbra, reckless, careless, because we don't count that as a mistake or as an error. So the maximum possible error will be always the least count type. Any measurement if I say 5.23 height, the least count will be 0.01. Let's write it again. If I say 5.23 sangbo object le height the magi least count to kya tani length si with least count to 0.01 tani. So the value may lie between kya, subtract this from this and you get some value, to add this to this, you get some value. Anyway, so why are we studying all this? Question DC ma'am significant figures ki concept se build up to to understand the concept of significant figures thoroughly. Rules and regulations you may solve the problem, but thoroughly understand so you need these concepts. Now another approach another important accident talk about garima say and the garima yes we yek tasu yek subdi kai di gari se ko garima koina garima kana thau laga nangina mangda phat ong break phar ka lep khre kana thar maga centimeter am ki gap ta ko sigi centimeter am nang kalau dine ba it can save your life break the phaba matang cha hob degi. Or you miss an accident by a second am the accident am nan tho ure it can save your life. Likewise, there are many critical situations like 0.5 mg java heart ki patient amado 0.75 mg prescribed torga pizaru buda chabda complications like by si gibe patient to ana ba hen soktan gibe bp guli na har wari buko aduna bp guli ogra heart ki guli ogra kitang critical of situation haning is ko aduna there can be error, no doubt. 0.5 mg dakata mido if you 0.5 mg dakata 0.6 mg but maybe problem kitang talk pe as not serious as this. Aduna in some situations or professions like pharmacy gi hidak sari missing ko aduga chemist sing ko chemist haidi hidak sa basing do or engineer sing gari ma design to matam da speed to break to chana na sa kadi mi ma'am si be second am da mi si do ni centimeter am henjan da saru tek turim ni yantai ko aduna there are some critical professions scientists doctors or engineers or chemists moi ma'am na significant figures ki concept kop na holok matam da si darka tare because moi gi kasin pham do it can cost life ever punsi ma sok pe mang be na bhen ki be si be ko aduna we apply all this concept there aduna chemistry the significant figures ki concept yaro se du gini ko so si mayam se kitang revise tar ga layu ko kitang khang ga layu si build up se noi si khang rabu to kisu kaide adu at least noi da knowledge ki framework ma pina hona bo ne enter is anyway so far if you have any doubts you can ask this on the SMS, WhatsApp, Telegram. I don't know. Do what you can. Go. I'll see you in the next video. Our next topic will be on significant figures. Significant figures. I'll see you in the next video.